Hi guys, so here's the third video. Now, so what we'll be doing is from the previous slide involving the composition of functions and the domain. Here's how we look at it uh, algebraically. So if you remember, we did here's F, G, and H. I will be looking at my tablet most of the time, so bear with me. So um, let's look at the domain specifically to illustrate, graph the domains of the individual functions. Starting with f of x. Here we know that we cannot have 3 in the domain of 3 of x in the domain of f of x. So let's mark 3. So here, cannot have 3 in the domain. For g of x, all real numbers allowed. While for G, for H, again, this one tells us that you can only use numbers between, not between, you can only use numbers less than or equal to -2 or greater than or equal to +2. So let's mark where 3 is for f of x. Let's say that's 3. Cannot have 3 in the domain, so the domain of f is represented by this graph. For g of x, all real numbers are allowed, so we can shade every value here. It's also marked 3 there. While for h of x, let's put the 3, so it's going to coincide and overlap properly. We cannot have 2, or we cannot have certain part of this line. Uh, can make use of 2 because it says it's greater than or equal to 2, and we also can use numbers less than or equal to -2. So there, that's how their domains um, match up. So if we go back to the slide earlier, let's consider the function f minus g. Then we have h over g. Then we have g of h and f of h. Let's take note of these functions. So for f minus g, again, we simply take the values that will work for both f and g. Since f doesn't work with 3, f minus g won't work with 3. So the domain of this one is the domain of f minus g will also be this one. Now, h over g. H involves the square root of x squared minus 4, and g of x is a polynomial function, 3x squared plus 4. Again, because x squared plus 4 here, that will never be 0. We do not have real numbers that would make x squared times 3 negative 4, become negative 4. So, hence, it allows all real numbers. But that's just for g. H of x here is x squared minus 4 inside the square root. So, again, the idea is we get what's going to work for both functions involved, h and g. For g, though it allows every real number in this domain, h will not allow real numbers which are between negative 2 and positive 2. So we cannot have that for h over g. So that's why h over g follows this domain. Now let's look at f of h. Oh, g of h. Start with g of h. Now, then we know the restriction for h. We don't have a restriction for g. But because h is restricted, that restriction should carry over. We cannot use the values that are not used in h. So that's why g of h also takes up this domain. But what about f of h? Now for f of h, it involves the denominator x minus 3 and the radical x squared minus 4. So again, comparing these two, we simply need to take what's common for both of them. So we end up with, for f of h, this is common for f of h. So I'll just use a different color now. That part's common for f of h. This part's common for f of h. And that part's common as well for f of h. Hence, for f of h, its domain will be composed of all numbers less than or equal to negative 2 together with all numbers in between 2 and 3, but 3 is not included. And